Let me get started, and I'll start from the very basic stuff, okay? Because basics are very important, and you can tell me what you're comfortable with, what you're not, and then from there we'll go on decoding it. Okay? So let me ask you very late questions to begin with. How comfortable are you with sine and cosine graphs?
Like 7 or 8 out of 10.
Out of 10. Okay. So because all that you have been asked to do in the class right now, it's a function of the key building blocks of sine and cosine functions. Okay. So let's look at them real quick. What I'll do is I'll put a unit circle by the side. Okay. And these are the 4 points. This point is 0. This point is 1 comma 0, because cos of 0 is 1 and sine of 0 is 0. This is 0 comma 1, yeah, which is representing cos of pi by 2 as 0 and sine of pi by 2 as 1. This is minus 1 comma 0, which represents cos of pi equals minus 1 and sine of pi is 0. And this is 0 comma minus 1, which represents cos of 3 pi over 2 as 0 and sine of 3 pi over 2 as minus 1. And again, if you forget about unit circle, this length being 1, these are the coordinates basically. Now look at sine of x. If I'm trying to plot sine of x, okay, referring to this unit circle. For sine of 0, let's say this is 0, this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi. Yeah. So when I talk about sine of 0, I'm talking about this point. Yeah. Sine of pi over 2, let's say this is 1, this is 2, this is 3, this is 4. Now I'm just bluffing right now, because sine of any angle will never go beyond 1. Yeah. So even if I put 2, 3, 4, let's not worry about it. So if I'm talking about sine of 0, y equals sine of 0, that is 0. Sine of pi by 2 is 1. Sine of pi is again 0. 3 pi over 2 is again 1. 2 pi is again 0. You're going to go to the same point. And hence the sine curve looks like this. The simplest, easiest, cutest form of sine x. Now, if I say I would want to plot sine of minus x, then I'm traveling in this direction, clockwise direction. Sine of minus x, when x is 0, same point, you are starting from this point. Sine of pi, when x is pi by 2, that becomes sine of minus pi by 2. You are coming to this point, which is minus 1. When you go to x equals pi by 2, pi, you are coming to this point, and again 0. So it meets this point. When you are going to 3 pi over 2, when x is 3 pi over 2, this becomes sine minus 3 pi over 2. You are coming back to this point, and this is again 1. And then after 2 pi, you come to this point. So what happened was, when you change the sign, you flip this. So it was going like this, you flipped it like this. When you do a minus of any angle, you are flipping it by this. Okay? Now, so this was for sine of x. Yeah? Now if you try doing it for cos of x, what happens? And again, I'm talking about the basics which you already know, but I'm just, first thing we saw was when I'm changing the sign of any angle to negative, it flipped, like take a mirror image of that across the x-axis. And one thing you would have noticed was this was going to 1. This was my amplitude. If I had 2 of sin x, it will go to 2. So basically same thing becomes taller. Yeah? This part is okay. And again, I'm doing for a reason, okay? So bear with me. So this amplitude actually stretches your graph. Now, if I make it instead of 2, if I make it 1 by 3, it will squeeze the graph. It will become something like this. Yeah. Now there is one more thing. So here, what you are seeing is, you are clear about the period part of it, right? So a period tells you how much it travels. Yeah, Arush. So Arush, today we are talking about sine and cosine curves or graphs and then transformation of those. Okay? So this is going to be a very interesting class, depending on how much you have dealt with in the past and what is coming new to you guys. Yeah? Arush, is that okay?
Yeah.
Okay. So it is not okay unless you turn the video on. No. Yeah. So again, I mean this is one of my aspirations to see all my kids. So, and for Vedansi it'll look a repeat of it, but it's okay. So again, the same question to Arush also. So Arush, how comfortable are you with the sine and cosine graphs? Have you come across this before or something new?
I know what it is, but I haven't done it.
I'm sorry, man?
I know what it is, but I haven't done it.
Okay. Fine. So I will start from scratch and see where do we land. So this is, I'm trying to plot y equal to sin x and y equal to cos of x. Okay? And on the side I have drawn a unit circle. I hope you guys can see the full board, right? You can see where my fingers are moving. Okay. So here, this is a unit circle. And what I've done is, these are the points, right? When angle is 0, the coordinates of this one will be 1, 0. When angle is pi by 2, my coordinates will be 0, 1. Right? This is cos pi by 2, which is 0, and sin pi by 2, which is 1. When I come to this point, it is cos pi. Angle is pi. Angle is pi. So sin of pi will be 0 and cos of pi will be minus 1. Here when I come to this point, this is 3 pi over 2, where my cos of 3 pi over 2 will be 0 and sin of 3 pi over 2 will be minus 1. This part is okay, Arush? Yeah? Now, I mean, unless I see a confident yes on your face, I will not move. Arush, is that okay, brother? Yeah, okay. Now, so this unit circle will tell us how do I graph it, okay? So this is 0. On this axis, I am plotting the angles, and this is x, the angle part, and this is the y, like what we are trying to plot. This is pi by 2, this is pi, this is 3 pi over 2, this is 2 pi. And I can go in this direction also, minus pi by 2, pi, 3 pi by 2, minus 2 pi. So when I am talking about sine of x, when x is 0, the angle is 0, sine of 0 is 0, right? So y will be 0. When talking about pi by 2, my angle is pi by 2, my sine pi by 2 will be 1, so this is 1. When my angle is 3 pi by 2, I am coming to this point, my sine becomes 0. When my angle becomes 3 pi by 2, my sine becomes minus 1. When my angle becomes 2 pi, my sine becomes 0 again. So if I join this is my sine curve. Yeah. So when you look at any sine graph, this part, this is the center of this line is called the midline. Okay. And the movement this side or this side, you will find that this is same. This is the maximum point, this is the minimum point, and you'll see that your midline is falling right in between these 2 points. Okay. So this here, if you look at the equation of this line, it will be y equal to 1, and equation of this line, it will be y will be equal to minus 1. The midline is y equal to 0, exactly in between. Yeah. So this is called the amplitude. The distance between the maximum point and the midline is called the amplitude, or you can say the distance between the midline and the minimum point is also called the amplitude. How tall the graph is, that's your amplitude. Now, if you put a 2 here, okay, let's forget about cos of x for now. If I put a 2 here, what will happen? Every value of sin x that you get gets multiplied by 2. So, if you are dealing with the equation y equal to 2 sine of x, you are talking about your graph getting stretched in both the directions. Okay. If I am talking about y equal to 4x, you are talking about your graph getting stretched in both the directions. Yeah. If I put a half, that's a different story. Now, so this is one part of it. So we saw that what is the role that amplitude plays when you are dealing with a graph. Okay. And here, let me do one more thing. And this will help you guys relate to a lot of stuff. If I am talking about y equal to, let's say, sin x minus 2, or y equal to sin x plus 2, what happens? This is my graph for y equal to, this is 0, pi by 2, this is pi, this is 3 pi over 2, this is 2 pi. And this
Does
is...
it shift the midline up or down?
Yes, I'll do that in a layman way, okay? So that, so we saw that my sine of y equal to sine of x draws like this. When I have a minus 2 here, whatever value we get here, for every point, let's say we are talking about y equal to pi by 2, which is 1. When I'm talking about, let's say y equal to 0, sine x equal to 0. So this value y will be minus 2. So we are, instead of starting from here, we are starting our graph from minus 1. Let me put, this is minus 1 and this is minus 2. You will see that your whole graph shifts. When x is 0, you are starting from minus 2. When x is pi by 2, you got 1 minus 2. You are striking minus 1 here. So whole graph shifted by 2 points. So when you look at a graph, when you have a constant at the end, that determines or tells you what is happening with your midline. So here, your midline was here at y equal to 0. Here it has come to y equal to minus 2. Basically, you put x equal to 0, make this one 0, and then whatever is there, that is your midline. Yeah. Similarly, if you are talking about y equal to sin x plus 2, same thing. Instead of starting from here, your graph starts from here. This part is okay? So, what we have seen is, we saw how the graph of sin x can be drawn and what is the impact of a coefficient here or a constant here. Yeah. When you are putting, instead of, if you have nothing, that is 1. If you are putting 2, you are stretching your graph. If you are putting half, you are squeezing it. Yeah. So this is with respect to sine of x. Let's look at what happens with, if I am talking about, so far we saw y equal to sine of x, some constant here, some constant here, some coefficient here, some coefficient here. What happens if I put instead of putting a sine of x, I say sine of 2x.
It's a horizontal dilation, no?
Sorry, brother?
It's a horizontal dilation. Like it's just the period.
Right. So here in this graph, let me say this is 0, pi by 2, pi, 3 pi over 2, and this is 2 pi. When I'm talking about sine of x, I'm talking about going from here till here. Okay? This is my graph right now. I know this looks stupid, but still it's a graph. Okay? Now, when I have a 2x, so in this graph, this 0 to 2 pi is my period. Because it makes one complete cycle at 2 pi and then starts a journey afresh. Okay? Beyond that. So at every 2 pi, this whole graph repeats. And you can see that from the unit circle also. All the values change up till here and then the whole cycle repeats. The whole cycle repeats. The whole cycle repeats. Yeah? So if you are dealing with a very simple, easy sine of x function, your period is 2 pi. If I put a 2 here, what is changing in this case? Are you sure with me, right? So far? Okay. If I am putting a 2x here, what is happening here? So let's look at it. This is my original graph, I am putting a 2x here, meaning when x is 0, this is 2 into 0 will be the same, so this is same point. When x is pi by 2, so this becomes 45 degree. When x is pi by 2, 2 into pi by 2 became pi by 4, which is less than 1 obviously. 1 by root 2 is probably 1 by 4.6 or something. So it will be somewhere here, somewhere.
Pi by 2 just equal to pi.
Yeah, that's what I'm coming to. So somewhere here below 1. When we make it pi, when this is pi, x is pi, I'm talking about sine of 2 pi. Sine of 2 pi is coming back to this one. It comes to here. What did I do? When x is pi by 2, this became 45. When x, what? This is where I'm going wrong. Probably I'm getting old. Sine of 2x, that's what I'm talking about. When x is pi by 2, that means this is 2 into pi by 2, that is, this is pi, we are talking about pi. Yeah, you are right, brother. So this is the first point and this is the second point. When x is, let me try relating to it a little bit more.
Wouldn't it be like the y value, like for the sine graph would be the y value for the pi?
One more time.
So like for pi by 2, does it in the transform graph, the
It's shrinking. I mean, again, I'm just trying to put that in a very simple way. Okay, let me pick up some angles like y equal to 0, 15, 30, and 45. Okay, I'm picking up these angles. Okay, so when x is 0. When x is 0, this is 0, so this is the same point. When x is 15, 15 is what? Pi over 12. Okay, so I'm talking about something here. Okay, so when x is 15 degrees, it becomes 30, so 1 by 2 here. When x is 30, it becomes 30 as in pi over 6 into 2, this becomes pi over 3, which is, this part becomes pi over 3, which is root 3 by 2. Root 3 by 2 is 1.7 divided by 2. It is somewhere around this. When it's pi, when it's pi over 2, this is when x is pi over 2, this became pi, which is 0. Okay, yeah. And when pi was 45 degree, yeah, wonderful, yeah. Now I'm going to do a better representation of this one. Okay. So what's happening is, when you're multiplying by, let's say 2, what's happening is your period, which was 2 pi, it shrank by half. Instead of going all the way till 2 pi, your whole thing will repeat after pi. Are you so convinced or not convinced? So what we're trying to draw from this thing is, when you have a normal sine function without any constant coefficient, it has period of 2 pi. When you multiply it with the coefficient, whatever be the coefficient, it shrinks by that, the graph by that factor actually. So if you put a 2 here, it shrank by 2. So your period becomes 2 pi divided by whatever is your coefficient, and your period got over at pi. If you're talking about sine of 6x, if you're trying to draw this, what will be a period? Period will be 2 pi divided by whatever is your coefficient here. If you're talking about y equal to sine of x by 2, then your period would be 2 pi divided by whatever is your coefficient, which is 1 by 2. That is 2 pi into 2. So basically, when you are dividing by number, you are stretching it. When you are multiplying by number, you are shrinking it. Yeah? Same thing applies for cos y equal to cos of x as well. So let's look at the summary of it so far, whatever we have discussed, because this is going to be a building block for us and Nancy and others must be thinking that our teacher did not come prepared for the class. So see, the thing is, I don't memorize things, I relate things, right? So that's why I was trying to relate to it, so that it stays with us longer. So we saw that if I'm talking about sine of x, this is my graph, this is 0, this is 2 pi, this is pi, this is pi over 2, and my graph goes like this. If I put here when x is 0, when x equal to 0, that gives me my midline, and that determines what is the line that is splitting this graph into 2 equal parts. So here my midline is y equal to 0. If I end up having something like this, my whole graph shifts by this many points, positive or negative. That is one thing. Next thing we saw was, if I have a function where I have a coefficient to the x be it 2 or be it 3, be it 1 by 4, my period changes by dividing by this number. So it actually shrinks the graph. Or if I have x over 4, it expands my graph or stretches my graph. Okay? So this is with the cos function. Similarly, if you have to, this is y equal to sine of x, and this graph like this. This is 0, this is 2 pi. Now if I have to draw y equal to sine of minus x, this is what I was explaining with Ansi before others joined. If I am talking about minus x, same thing happens. I am measuring my angles in the clockwise direction. So here x, when x is 0, same point. When x is pi by 2, I am coming to this point, and hence my y value becomes minus 1. When I am going to x equal to pi, I am coming to this point, my x is again 0. When I am coming to x equal to 3 pi over 2, I am moving this way and coming to this point, and then my x is 1. And when I make x equal to 2 pi, I mean minus 2 pi, I travel all the way and come back to the same point, and that is 0. So what we saw was, when I put a negative against the angle, my graph flips. Okay? So what I will do is, now we will just quickly look at the graph of y of cos of x, and then we will go on decoding some of the problems that you guys will deal with. So y equal to cos of x. Nothing changes from approach point of view, same unit circle, same graph paper. This is your x, this is your y, this is 0, pi over 2, pi, 3 pi over 2, 2 pi. Now and this is 1. Value of cos also oscillates between 0 and 1, minus 1 and 1. So look at when x is 0, when x is 0, angle is 0, cos of 0 is 1. You are starting from here. When x is pi by 2, you are coming to this point, and your cos is 0, you are coming to this point. When x is pi, you are coming to this point, and your cos value became minus 1. When you went to 3 pi over 2, your cos became 0 again, here. And when you went to, when you made a complete 2 pi, your x became again 1. So starts from here, goes here. 3 pi over 2 is 0. Am I drawing it right? Okay, 0 is 0, pi over 2 is 1, pi over 2 is 0. Two pi, okay, sorry, that's what I was wondering. This is where it's coming. So at 0 it's 1, at pi by 2 is 0, at pi is minus 1, at 3 pi over 2 is 0, and at 2 pi it has come to the same point. So here also if you look at the period, it's 2 pi. Your amplitude again, same thing, is 1. This is the maximum point, this is the minimum point. Your amplitude is again 1, here or here. And the only difference you saw was between your cos of x and sine of x. Your sine of x starts from here, your cos of x starts from here. That's the only difference. Everything else will remain the same. So we saw what happens when we do a minus of sine of x, it flips. Same thing will happen with cos of x also. So you have it here, when you do cos of minus x, it will start from here. and go like this. This is the basic premise of how you would look at any sine function or cos function. Now, here comes some questions, okay? Let's say if I draw a graph, and Didachi, you might be able to relate to this one. So this is, let's say, 1, this is 2, this is 3, minus 1, minus 2, okay? If you have, let me pull up a graph. Let's say, if I have graph going from here and this, and you have been asked to, okay, and you are given this is a minimum point, the coordinates are 1, comma, and here the maximum point coordinates are given as 3. This is, let's see. Let me pick up some legitimate problems, okay? Otherwise, I'll keep getting you guys confused. Okay. Let's say I have, okay, I should have put some questions in the WhatsApp group. We have a question which says the graph of sinusoidal function intersects its midline at 0, 2. This is where it intersects the midline at 0, 2, and then has a minimum point at 3, minus 6. What is the formula for the function where x is entered in radians? So this is the midline. The graph of the sinusoidal function intersects its midline at 0, 2. So if you have this one, 1, 2, it intersects its midline at 0, 2. So this is the midline, okay? It intersects at 0, 2, this point. And then has a minimum point at 3, minus 6. So 1, 2, 3. And this is, let's say, minus 2, let's say this is minus 6. It intersects as a minimum point at 3, minus 6. Okay? You have been asked to write the formula for the function. How would you go about it?
First, we know the midline is 0, 2.
0, 2, yeah.
You would have the d value to be plus 2.
So, yeah, so here what the way you will do is sine of, let's say, x pi, okay? Yeah? Or cos of x pi plus 2. So, we don't know whether it's a sine function or cos function. Now it says it is the midline and touches the minimum point at 3, minus 6. So what this information is giving us?
It gives us the midline and the amplitude.
Amplitude. So here there was a constant here which I did not put, but now we see that it is 2 and this is coming to minus 6. So the total distance between 2, it will be 8. So we are talking about the amplitude of 8. So 8 cos of x pi plus 2 or 8 sine of x pi plus 2. Correct? Now let me see if there is any other information in this question. The graph of the sinusoidal function intersects its midline at this and then has a minimum point at 3 comma minus 6. Write the formula of the function where x is entered in radians. Okay. Now, there's one more information here. The the function intersects its midline at 0 comma 2. Okay? 0 comma 2. What does it mean? When x is 0, it is intersecting the midline at this point. And look at this one. When x is 0, this guy will be 8 into 0. 8 into 0 into something. So cos of 0 will be 1. 8 plus 2. This point will be 8 plus 2, 10. But touching this at this point. Okay, I think, let me make you guys think. This graph is intersecting at 0 comma 2. So you have two options. You know that your amplitude is 8, so this constant you have put. You know the midline, you have put that here. You're still figuring out whether it's a cos function or sine function. Now, the graph is intersecting at 0 comma 2. That means the graph is going through this way, whatever way. Okay? But that is when x is 0, meaning that when the angle is 0. Now, when the angle is 0, if it was a cos function, when angle was 0, this x was 0, this would have been 1. And at this point, the value of y would have been 8 plus 2, 10. But at this point, since this is intersecting, so at this point y value is 2 and x value is 0. So cos is out of question actually, because this makes it 10. Now look at x situation, sine situation. When x is 0, sine of 0 becomes 0. So 8 into 0 is 0. So this point satisfies this graph. Yeah? Am I making sense, Arush? No? Okay. Yeah, okay. Let's look at another question. Probably that will give us some clue. Okay? Some more clue. Now, there's one more thing.
But wouldn't you write a function still for cosine?
Ex-
You could show a phase shift, no?
No, so again, so far, no, cosine is out of question because when x is 0, my cos value gives me 1. Cos 0 is 1. So cos is out of question. So we are only leaning on sine function. So my sine function, so basically my option that we are left with is 8 into sine of whatever, let's say pi x plus 2. This is the function. We have still not found what is the value, the constant here.
Yeah, so
Sorry, I'll say ax, not pi x. Okay, yeah.
for us, we're told that we might be given something like this, and we will have to include the phase shift and horizontal dilation to make the cosine function. And
Okay, so the horizontal dilation is what we are trying to figure out right now. So, first thing we have done is we found the midline, then we found the amplitude. Now we are trying to find out what angle we are talking about. Are we talking about y equal to 8 sine pi over 6 plus 2, or we are talking about 8 sine pi over 2 plus 2, or anything else, right? So this coefficient that you have to multiply with x, that we have not found out yet. Yeah. So here, let's look at this. And the dilation, that, like you said, that's what we have to look at. Here, between this point and the minimum point is 3 minus 6. How much you are traveling between, for x value?
3.
3. right? So what clue that is give? That does that give? What would be the coefficient that we're talking about?
Assuming like it is the midway of the period, then the period would be like 6.
Period would be 6. Yeah. Yeah. Correct. I'm just assuming so basically, see, now let's draw a simpler looking graph to relate to it. When we were drawing, now we know that this is a sine function, okay? When we were drawing sine of x, this was pi over 2, this was pi, this was 3 pi over 2, and this was 2 pi. And it was going like this. And here, my period was 2 pi. And between the midline, this one and this one, my gap was how much? Pi by 2, correct? Here also we know the midline and we know the minimum point. Between the midline and the minimum point, we see how much it is changing. Yeah? It changes by pi over 2. My total period is 2 pi in this case. But in this scenario, what you are seeing is it changes from 0 to 2 between the midline, right? So your total period is always 4 times of this gap, pi over 2 times 4, right? So here you are talking about this dilation by how much? 4, right? Okay. So here our period is how much? 4 times of this one. 12. So for us to get a period of 12, what will you do here? Let me put that in a language that you guys can relate to. So
6 divided by pi.
exactly. Correct. So when my period is 2 pi, I'm talking about x. When my period is 12, I'm talking about 2 pi over 12. Yeah, that makes it pi over 6. So we are essentially talking about this as y equals 8 sine of x over 6 plus 2. Making sense? Not making sense. Oh, sorry. Pi over 6x. No? So, relate this way, okay? So, when this thing is, so here we are not saying x. Sorry. Let me collect my thoughts. Simple thing is, or let me give you guys a dirty technique. So there's a way to write the sine function, that is a of sine x sine bx plus c plus d. Okay, where d is your midline, a is your amplitude, and B plus C. I will probably park this C thing for now. Okay. Here what B says is, if whatever be the value of B, that gives you the amplitude. What we found is our amplitude is 12. 12. So what do I write here? For simple x, if it was only x, my amplitude was 2 pi. Sorry, my period was 2 pi. What do I put here to get a period of pi over 6? Yeah? So let's look at this one. We got this this whole amplitude was for 12. Okay, so 2 pi, you always do this value of B is 2 pi over B. So you are eventually let me put that in the right words. Let me just tell you the right term for this one. Okay, let me put this one. Okay, yeah. Okay, now I can do that in a simple way. Okay, so I was kind of not getting the right word. So this is how you derive your function from the graph. Okay, it says that if you have learned what is the amplitude, and you have figured out that this is sine function, then your period will be determined by the B. Okay, if there is nothing here, then we are talking about this is determined by so the period of function is always a period as in let me get a 30-second break. I'm just thinking if I'm right. All right. So what we have found from the question was that our midline was 0, 2 and the minimum point was 3, minus 6. Correct? Now this is between the midline. Let's say this is my midline 0, 2 and the minimum point here. Midline to the minimum point, this only covers how much? 1/4 of the entire period. Correct? 1/4 of the entire period. What is my period here then? From here to here, it is 1/4 of the entire period. So I am talking about my angle being 0 to I'm covering only 1/4 of the period. So total period would be 3 into 4, and that is what is my B. Okay. So my B is 12. The entire period is 12. Okay. Now, if you guys remember it, I was talking about, if I'm talking about sine of x, my period is 2 pi. If I put sine of x by 2, my period becomes 2 pi 2 pi divided by 1 by 2, that is 4 pi. Correct? If I put sine of 2x, then my period becomes 2 pi over 2, that is pi. Meaning, when I multiply it, I keep shrinking it. When I divide it, I keep expanding it. Okay? So here, whatever be the coefficient that we put here, that divides or multiplies the period. Okay? So, in this case, we know that my period is 12. So, this is 12 and so for us to get a period of 12, okay, so when my coefficient is 1, my period is 2 pi. When my coefficient is 12, my period is 2 pi over 12, that is pi over 6. That's what I was trying to relate to. So in this case, this is an equation. I mean, you don't really have to worry about the determination of that. The simple thing is, from this equation you found that this minimum, the midline to the minimum point is 3. So my period would be 4 times of that, and that's what you will put in this equation. So you got A equals 8 sine of 12x plus c. This is your equation basically.
Isn't it supposed to be 5 or 6?
It's supposed to be pi over 6. That's what I was. Yeah. So this is supposed to be pi over 6. My bad. So for us to get a period of 12, this value has to be pi over 6. That's what we calculated. So that's what. So this becomes your equation. Okay. Let me. I think I lacked a little bit of practice. I should have done. Let's do it together for next 10-15 minutes. Yeah. So let's look at next question. I think this time we'll probably do a better job. I mean, I will do a better job. Okay. So now let's look at this. The next question says the graph of a sinusoidal function has a maximum point at 0, 10 and then intersects its midline at pi over 4 plus 4. Find the function. So you guys will get for Vidansi, when you have a test coming up, you will get a question where you will have a graph given to you, and from that you can determine, or you can have these values given to you, from that you have to determine the function.
When we are given values, it's more of a word problem.
Yeah.
Like, I remember we got a question, like, it was a pretty weird question, I'll tell you that there's a clock 120 inches above the ground, and the minute is 8 inches, and goes twice as fast around the clock. And then you first make a graph of it, and then you write cosine and sine functions for them.
Okay. So basically again same thing, we'll have to break it down. So let's look at this question, okay? It says, let's try solving this. If we are able to solve it, okay, then we are fine. If we are not, then teacher has to do a better job in the next class for sure. Okay. So these are 2 points given to us. Graph of sinusoidal function has a maximum point at 0, 10 and intersects its midline at pi by 4, 4. What will be the function? What will be the formula for the function? So again, same thing. I will do that in the simplest possible way that I can think.
Cosine,
I'm sorry, Peter?
it would be naturally a cosine function.
You might be smarter than me. I'm still thinking about it. Okay. So this is what it says. Let me put that in the graph. Has a maximum point at 0, 10. So this is, let's say 5, this is 10. Maximum point at this point. So whether the graph is going, okay, so graph is going this way for sure. Yeah. This, because this is the maximum point, right? So this is not going this way. This is going this way. Okay. And then intersects its midline at pi by 4. This is pi by 4. Okay. So intersects its midline at pi by 4. So it's coming this way. Come up pi by 4, come up 4. So as you can see, this is the maximum point, this is the midline, which is 4. So essentially your amplitude is 10 minus 4, which is 6. So, and then as you rightly said, this is a cost function because at x equal to 0, this is the maximum point. When x is 0, it's touching the y-axis at some value. So that means y equals a, let's say, cos bx plus d. And let's try plugging in the values here. My d is nothing but the midline, which is 4. So I'll put a 4 here. My amplitude is given as 6. I'll put a 6 here. And it's a cost function. Yeah. And again, what you see here is between the maximum point and the midline, this is 1/4 of the entire period, which is pi over 4. Yeah. So pi over 4 is 1/4. So the entire period is pi. So it is squeezed by half. Yeah. So squeezed by half. 2. Yeah. Yeah. I was able to connect the dots better this time. And it happens, okay? So what I'm teaching you guys, I studied that 35 years ago and I'm just trying to relate it, right? So let me confirm if this gives the same answer. So we got 2, this value of b as 2. Sorry. What is it saying? This is oh no, sorry. I was looking at the answer for the wrong question and I was wondering what's going on. Yeah. So we got it, right? So this is 2 because it's simple, right? I mean we see that okay. For 2 pi it would have been just x. We are looking at 1 pi. We already have the value in pi, so we don't have to worry about all that. So 2 pi would have been full x. We are talking about the whole period being just a pi. So this becomes 2. That's how we translate the period to be 1 pi. Now we are top of the hour, but a question to Vedansi. Is this, whatever we have done, something right, something wrong, is this giving you that confidence that you want to take the test or you're still a little worried?
I'm not confident in my X's and my B values and my C values.
Okay.
I mess it up always.
Okay. So what I would suggest is you pick up few sample problems, okay? Try solving them and send it to me. Okay? And then if I find something to be corrected, I'll give you that. When is your test, by the way?
December 9th.
December 9th, which is Tuesday. So between now and tomorrow, try working on some problems, validate your approach. See, ultimately it's all about breaking it down, okay? Finding out the amplitude, finding out the midline, finding out this relationship here. If always, whenever you have a problem, whether you have a graph or a word problem, just try to do a, what you call, scratch work and see how you relate to it. How do you find out the period? How do you find out the midline? How do you find out the maximum, minimum? How do you determine whether it's a cost function or sine function? And then try plugging it here. And then if something goes little complicated, send me those questions. I will try to take a look at it and give you some clue. If I'm getting confused, I'll borrow some clues from somewhere. And what we'll do is, today we just touch the surface of it. In the next class we'll practice a little bit more, because my main concern is, I have told you guys just something in a very quick way, because knowing that there is a test coming up. But I certainly want to go deeper into this concept, practice few more problems, be more confident about it, and then so that this concept remains with us. Yeah. So next class we'll again go to this one, solve few more problems. But for now, Vidansi, just try solving few problems. Let me know if there's something bothering you before the test, and we'll work on it. Yeah. Okay. All right. With that being said, I'll let you guys go have some fun. Yep. Bye bye.